I will discuss uniformly accelerated motion, or UAM, which describes the motion of a body with a velocity changing at a constant rate. Examples of uniformly accelerated motion will be a ball rolling down an incline, or a car starts to run from rest, or the moment you have applied the brakes on a running car until it comes to a complete stop. We will use the three kinematic equations, which are Vf is equal to Vi plus At, or D is equal to Vit plus 1/2 At squared, or Vf squared is equal to Vi squared plus 2Ad. These equations have 5 variables, namely Vf stands for the final velocity expressed in meter per second, while Vi stands for the initial velocity. Again, it is expressed in meter per second. D is for the horizontal displacement expressed in meter. A is for acceleration in meter per second squared, and T is for the time elapsed expressed in second. We will now solve sample problem number 1. An aircraft accelerates down a runway at 4.20 meter per second squared for 30.0 seconds until it finally lifts off the ground. Determine, letter A, the distance traveled before takeoff, and letter B, the velocity just before takeoff. To solve the problem, we will first write all the given information. For the final velocity, it is unknown. For the initial velocity, it's 0. For the acceleration, it's 4.20 meter per second squared. For the displacement is unknown, and time is 30.0 seconds. For problem letter A, so we will be using equation D is equal to Vit plus 1/2 At squared. So therefore, substitute all the given values to the formula. So this will be 0 times 30.0 seconds plus 1/2 4.20 meter per second squared times 30.0 seconds. This will be squared. Okay, so this will be 0 plus 1/2 times 4.20 times 30 squared will give us a value of 1,890. So therefore, our answer will be 1,890 meters. The solution for problem letter B will be, we'll be using the formula Vf is equal to Vi plus At is equal to 0 plus 4.20 meter per second squared times 30.0 seconds. 4.20 times 30 will give us a value of 126 meter per second. So therefore, the takeoff velocity will be 126 meter per second. Let us now proceed to sample problem number 2. A car traveling with a velocity of 80 km per hour to Manila can apply the brakes to stop within a distance of 35 meters. Determine its letter A, acceleration, and letter B, its stopping time. To solve the problem, we are going to write all the given information. For the final velocity, it's 0. For its initial velocity is 80 kilometers per hour. But we are supposed to express units in meter and second. So we will first convert this to meter per second. So we will use the factor label method. So convert this to kilometer at the denominator and meter at the numerator. So the relationship is there are 1,000 meters in 1 kilometer. Cancel the kilometer. Next, 1 hour will be on top, and at the bottom will be seconds. Wherein the relationship is that in 1 hour it has 3,600 seconds. Cancel the R. So the remaining unit is meter per second. So our initial velocity therefore will be equal to 22.2 meter per second. Next, the displacement is 35 meters. The acceleration is unknown and time is unknown. For the solution for problem letter A, we are going to use the formula Vf squared is equal to Vi squared plus 2AD. Next is substitute all the given information to the formula. So for Vf squared, or the final velocity, it's 0 squared. For the initial velocity, it's 22.2 meter per second squared plus 2 times A, the unknown, and the displacement, which is 35 meters. Transposing this value to the other side of the equation symbol, this will be minus 22.2 squared. We'll also do the same thing to the other side of the equation symbol. So this will be minus 22.2 squared. So this will become 0. And this one will be negative 22.2 squared is equal to 70A. Transposing this value to the other side, so we'll divide this by 70. So do with this side of the equation symbol. So our final answer, therefore, for acceleration is negative 7.04 meter per second squared. For question letter B, we'll be using the formula VF squared, VF. For question letter B, we're going to use the formula VF is equal to VI plus AT. Again, substitute all the given information to the formula. So we'll have VF is 0, VI is 22.2 meter per second, plus acceleration, this value we have just, the value that we had just calculated, which is negative 7.04 meter per second squared, times time, t, unknown. Okay, so transpose this to the other side. So this becomes, so this will be plus 7.04 t plus 7.04 t. This will become 0. And this will be, the 22.2 will remain here. And this will be 7.04 t. Okay, we'll transpose this value to the other side. So this will be divided by 7.04. Divide this by 7.04. So our t, therefore, 22.2 divided by 7.04 will get a value of 3.15 seconds. So that's it. Thank you for watching, and please subscribe now.